Okay, 7.7, and some other books put this in a different place, is another approximation method for finding the area under a curve. It's called the Trapezoidal Rule, for reasons that will become obvious here in just a moment. Now, if we're looking at this function f, okay, and let's say we want to find the area under the curve from A to B, and let's say, let's go ahead and divide it up into 4 subdivisions. Okay, that's easy enough. The ways that we've done it in the past required us to actually draw rectangles that were either justified to the left or to the right. Okay, so you either had a rectangle that came off like this and was justified to the function value on the left-hand side of the interval. Okay, and I hope that that's dark enough to actually see a little bit of. Or you had one where it was justified to the right-hand side. Okay, and so we had the left-hand Riemann sum and the right-hand Riemann sum. What we're doing here is we're sort of splitting the difference. Okay, so what we're going to do is, instead of using rectangles, we're going to use trapezoids, hence trapezoidal rule. Okay, and you may not actually see the trapezoidal shape right now, but let's go ahead and draw these little slant lines in. The trapezoids become very, very apparent when you start looking at it like that. Okay, and so if we see that, we see the fact that we have a trapezoid here. Okay, and we know that the trapezoidal area formula is something that we learned in geometry. And you have another trapezoid right here, and you have another trapezoid, even though it looks kind of rectangular, it's right here, and you have another trapezoid that's right here. Okay, and we'll call this base 1, and we'll call this base 2, and we'll call this base 3, and we'll call this base 4, and we'll call this base 5. Okay, just for lack of anything else better to call them. Well, I know that the area formula for a trapezoid, okay, area formula for a trapezoid is height base 1 plus base 2 averaged. Well, that would be the area of that first one. Okay, so let's go ahead and do the area by summing up the trapezoids. Now the first one is going to, and of course height right here, height is measured when we turn them into trapezoids like this, right? That is the height of the first one. That is the height of the second one. That is the height of the third one. And that is the height of the fourth trapezoid. But once I shift it back around and start looking at it in terms of its regular orientation, I recognize that all height is just delta x. Okay, so I have delta x base 1 plus base 2 over 2. Okay, let's do the area of this second one. Well, notice that base 2 gets used again because it's base 2 plus base 3 averaged. And then for the next one, it's supposed to be delta x, not just delta. Base 3 plus base 4 averaged, and base 4 plus base 5 averaged. Well, notice that the only ones that are not used twice are B1 and B5, the first function value and the last function value. And notice that all 4 of these have a delta x and a divided by 2 in common. So let's go ahead and pull out delta x divided by 2, and we wind up getting base 1, 2 times base 2, 2 times base 3, 2 times base 4, plus base 5. And if you have already been taught the formula, that ought to look really, really, really familiar. Okay? That is f of a plus 2 times f of a plus delta x plus dot, 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 plus, 2 times f of a plus blank delta x plus f of b. So the trapezoidal rule, you just have to remember that it's not delta x times all the function values. It's delta x divided by 2 times the sum of all the function values doubled except the first and the last. And then it has to do with the fact that, B2 is used here and here. B3 is used here and here. B4 is used here and here. But B1 and B5 are only used once because they are only a base for one trapezoid because they're on the outer edge of the interval that you're looking at. Now, that is the first way to look at the trapezoidal rule. Okay? Here's another way to look at it. Notice, I want you to focus on the top of this. If you take this box right here, that box right there is the difference between the left-hand Riemann sum and the right-hand Riemann sum. Notice that the slant right here, which creates the trapezoid, cuts that thing in half. Okay? Notice it's the same for here. Okay? The trapezoidal slant actually cuts these in half. So if the difference between them is cut in half, am I not averaging the left hand and the right hand Riemann sum? I mean, functionally, that seems to be what I'm doing. Okay, well, let's go ahead and notationally look at averaging the left hand Riemann sum and the right hand Riemann sum. So the left hand is going to be delta x, okay, times f of a plus f of a plus delta x plus dot, 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 plus f of b. Well, the right hand, or actually it's not f of b, it's f of b minus delta x, or f of a plus however many delta x's. So that's f of a plus n delta x, right? So the right hand Riemann sum doesn't start there, it starts over here, right? Dot, 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 plus f of a plus n delta x plus f of b. Okay? And notice what happens if you were to add these together. If you were to add them together, what would you get? Well, you're not going to get, the delta x is factored out of all of these, so that's not going to double. But you do get f of a plus 2 f of a plus delta x, right? The sum of those, plus dot, 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 plus 2 times f of a plus n delta x plus f of b. And then what do you have to do in order to, so that's the left hand plus the right hand, and what do you do in order to average it? Well, in order to average it, you would just divide by 2. And you have the formula again for the trapezoidal rule. So you can either think about it in terms of the area formula for trapezoids, or you can think about it in terms of just averaging the left hand and the right hand Riemann sum. Well, that's a helpful way to think about it because sometimes questions will ask you for the left hand and the right hand Riemann sum. If they ask you for the left hand Riemann sum and ask you for the right hand Riemann sum, and then they ask you for the trapezoidal approximation, don't redo the trapezoidal approximation. Just average the two answers that you already have. Okay? Well, let's go ahead and actually put this to use and actually do an example or two. Okay, with the time that we have left. Let's say, and let's do one that's really easy. Let's do an approximation of 0 to 2 of x squared dx, where I have n is equal to 4. 4 subdivisions. Okay? 4 subdivisions from 0 to 2 are obviously going to be at 0, 1/2, 1, 3/2, and 2. That's where it's going to mark it up, right? That's actually going to cut that interval into 4 separate pieces. So I know 0 to 2 of x squared dx is approximately, well, the delta x formula, remember, is b minus a over n. So in this case, it's 2 minus 0 over 4, or 1/2. But if I'm looking for delta x divided by 2, I have 1/4. And then I need f of 0 plus 2 times f of 1/2 plus 2 times f of 1 plus 2 times f of 3/2 plus f of 1. And of course, since this is squaring, it's actually relatively easy. 0 squared, 2 times 1/2 squared, 2 times 1 squared, 2 times 3/2 squared, or I'm sorry, this is supposed to be a 2 right here, plus 2 squared. Well, 1/4. This right here is going to be 1/4 times 2, or 1/2. So 0 plus 1/2 plus 2. This is going to be 9/4 times 2, or 9/2. And this is going to be 4. So that winds up being 6, the 2 and the 4 added together, and 5, the 1/2 and the 9/2. So that's 9. This winds up being 9/4 as an approximation. Well, how close is that? Well, this ought to be really easy to do by hand. You get 1/3 x cubed from 0 to 2, and that winds up being 8/3. Well, 9/4, of course, is equal to 2.25. This is approximately 2 point what? 6.7. Now, does it make sense? Well, it should. I mean, that's relatively close. It's really not all that bad in terms of an approximation. Okay. So let's go ahead and move on to the next one. Let's do. How about 0? So that's number 4. 0 to 8 of the cube root of x, and I want there to be 8 subdivisions. This is going to be a little bit of a pain in the neck to actually do by hand, but let's go ahead and do it by hand anyway. I happen to know that my delta x is equal to 1, okay, and therefore I know that my approximation is going to be approximately equal to 1/2, okay, and that would be 0 to the 1/3 plus 2 times 1 to the 1/3 plus 2 times 2 to the 1/3 plus 2 times 3 to the 1/3 plus 2 times 4 to the 1/3 plus 2 times 5 to the 1/3 plus 2 times 6 to the 1/3 plus 2 times 7 to the 1/3 plus 8 to the 1/3. Well, let's go ahead and work that out. It's going to be a little bit arduous. Just remember that if you press math, your cube root is number 4 down there. Okay, is it on one of these as well? I mean, I guess you could use that 6 one right there. You just have to plug in the 3. Okay. Okay. Let's go ahead and go back to here. Now, I know that it's going to be 2 plus 2 times 2 to the 1/3 plus 2 times 3 to the 1/3 plus 2 times 4 to the 1/3 plus 2 times 5 to the 1/3 plus 2 times 6 to the 1/3 plus 2 times 7 to the 1/3 plus 8 to the 1/3, which is actually 2. Okay, and then we just have to divide that by 2. Now, how close of an approximation is that to the actual answer? Well, let's go 0, since we already got the calculator out. Math for x dx, and come on. Okay, well that's pretty close. It's 0.27 off. So I mean, this is the imperfection in the algorithm. The answer is most likely exactly 12. And of course, 11.730 is not that far away. So that's a pretty good approximation by the trapezoidal rule. And the trapezoidal rule is good because it leaves less of a gap between the geometric shape that you're using to approximate and the actual curve, which is why the trapezoidal will always be a much better fit than the Riemann sums, the rectangular ones that we've been actually doing in the past. And that, that and a couple of other examples ought to serve you well on this one. This actually really isn't that bad of a section if you just remember the two ways to consider the trapezoidal rule. Pick which one you think is best, memorize the formula, and as long as you have a little bit of facility with your calculator, you ought to be just fine. In the next video, we're going to approach a couple of problems from kind of the obscure way that they can be asked at times, mainly by means of a table of values rather than being actually given a function to actually work with like we have in these last two examples. So go ahead and be looking forward to that.